I had a comment and a question from Messidor08 about combinations, and I thought rather than just reply into the comment, I would make a whole video on it. And fair warning, this is probably one of the most complex topics that I've covered so far in quant. So if you are at a lower level, you might want to watch some of the low and medium topics before covering this topic. Even though I pride myself on explaining things really well and making things very clear, this is a tough topic, arguably the toughest topic that comes up in the GRE or the GMAT. Although you could say that title goes to advanced probability or to functions. But either way, it's a really tough topic, and there are going to be 3 tough questions in ascending order of difficulty. I'm not going to pretend that this comes up all the time. This will only come up if you are at the highest level of quant for the GRE or GMAT, aiming for a 750 plus on the GMAT or a 170 on the GRE. Arguably, this first question is slightly lower than that level, but the next 2 get a lot harder, a lot quicker. And if Messidor is watching this, the second question is basically the one you sent me. I've just changed one of the numbers. But without further ado, let's tackle combinations with minimums and maximums. And in this first question, specifically combinations with the phrase at least. And just before we begin, I know many of you will want me to cover combinations mixed with probability, but that is for another day. This video is going to be difficult enough as it is. That's for a different video. This one is just going to be simply, purely combinations with minimums and maximums. So what about this question? There are 3 women and 4 men being considered for promotion. If 3 individuals are to be selected for promotion, in how many ways can at least 1 woman be chosen? So this is not a classic super simple combinations question. I'm assuming some knowledge in the people watching this in terms of they know the formula for basic combinations. If they don't, I'll do a very quick recap. I'm kind of assuming a bit of existing knowledge going into this video. If the question was simply asking how many ways can we select 3 individuals from 7 people to promote, that would be a simpler combinations question, and we would apply the formula that we know, and I'm going to show you in a second. But why is this question different? Because there's a minimum or a maximum. We need at least 1 woman to be chosen, so we can't select all the different options because there are certain requirements that we have to meet. How do we tackle such questions? There are just a couple of things you really need to focus on and concentrate on in order to get these kind of questions right. The first thing is a decision you have to make about whether it's easier to work out the thing that they're explicitly asking for or the opposite to what they're asking for. In other words, in this question, is it easier to work out all the different ways we can get at least 1 woman promoted? Or is it easier to work out the opposite of that? Is it easier to work out the probability that not at least 1 woman is chosen? Just quickly, how can we fail to get at least 1 woman? Well, by having 0 women. That's the opposite. That's the failure. Success is getting at least 1 woman. But notice how many combinations that is. 1 woman, or it could have been 2 women who were promoted, or it could have been 3 women who were promoted. Notice there are 3 different calculations we would have to do. The combinations for finding 1 woman, then 2 women, then 3 women. That's what we would have to do if we wanted to find out directly what they were asking for. But the decision that we're going to make is the decision to say that no, it will be easier to work out the opposite of what they want. How does that work? Well, it's basically this principle being applied. We're going to find the total number of selections possible with no conditions. Just what's the total number of ways we could select 3 people to be promoted. Forgetting men, forgetting women, just what's the total. Then we're going to take away all the different ways where we fail to get what we want, where we don't get what we want. In this case, we want at least 1 woman, so to fail means to get 0 women. So we're going to find out all the different ways of getting 0 women when we promote. And if we do the total minus what we don't want, then we will get what we do want. And this way is much easier because it's one calculation, 0 women, versus 3 calculations, 1 woman, 2 women, 3 women. And that's the first decision you have to make with these very difficult combination questions with minimums and maximums. Is it easier to get what we want or what we don't want? And in this case, it's easier to work out what we don't want. Let me demonstrate. What's the total number of selections possible with no conditions attached? Well, there are 7 people, 3 women, 4 men. Ignore the women and men, just 7 people in total, and we're choosing 3 of them to be promoted. So that's 7 choose 3. I've written 7C3 for short. Again, if you don't know what formula I'm talking about, you'll see in a second, but we're going to do 7 choose 3 using the formula for combinations, which I've explained in a different video. And then once we've got that total, we're going to take away what we don't want, which is we don't want to choose 0 women. And so we're going to take away that, and that's going to give us what we want. The formula that we're working with is this one, the classic combinations formula. N factorial over R factorial, N minus R factorial. If you aren't aware of that formula, I strongly advise you to watch my other videos before watching this one, because this is like the hardest version when you don't even know the formula. But basically, N is the total and R is the number of people or items that you are selecting. And that's the formula that will tell you the number of ways of selecting R people or R objects from a total of N. Just to show you how that works here, 7 choose 3, the N would be 7 and the R would be 3. And here comes the second key moment with this demonstration question. The 7 choose 3 is just applying the formula, but what about choosing 0 women? To solve these kind of hard questions, you have to think about what each choice means. You can't rush. You have to slowly consider what it would be to choose 0 women, what it would mean. In this case, choosing 0 women means what? It means that you're choosing 3 men. And then you've got to work that out separately, as I've written here. How many ways can we choose 3 men? Well, there are 4 men in total, and we're going to choose 3 men, because that means getting 0 women. Or in formulaic terms, 4 choose 3. 4 men in total, and we're choosing 3 of them. That was quite complicated, so I just want to recap. The 7 choose 3, the total number of selections possible, I think most of you will understand why we're doing that. Okay, that's no conditions, women and men, there are 7 in total and we're choosing 3 for promotion, 7 choose 3. And I think most of you would agree that not getting what we want means getting 0 women. So that's why we're going to take away the combinations for 0 women. But we can't just apply the formula to work out 0 women. We have to stop and think, how do we get 0 women? The only way we get 0 women is if we promote 3 men. And then we have to calculate that. The question is not just going to give it to us. We have to calculate how we can choose 3 men. How can we choose 3 men? Out of 4 in total, 4 choose 3 and apply the formula again. That's what makes it hard. You've got to think about the implications of each choice that you're making. Choosing 0 women means choosing 3 men, which means you have to calculate the combinations for choosing 3 men. Okay, now the actual maths isn't that hard. 7 choose 3, we can put it into the formula, and you get 7 factorial over 3 factorial, 4 factorial, and 4 choose 3 is 4 factorial over 3 factorial, 1 factorial. The 7 is the N, 3 is the R for the first example, the 4 is the N, and the 3 is the R for the second example. Now I'm going to work out the one on the left in full to show you how it works if you're not familiar with this. But the one on the right, I want to teach you a shortcut. Whenever you have these choosing formulas, if the total, the N, is only 1 bigger than the R, for example 4 choose 3, the result is always just N, in this case 4. It all cancels down just to leave you with N if the N is 1 greater than the R. So we don't actually have to work out 4 choose 3 because we know the result is going to be just 4. And that's a great shortcut that you can note down, and it will be useful in the next 2 questions as well. There is no such shortcut for the calculation on the left, so I'm going to show you how to do it in full. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 factorial. And then you can cancel out. So notice the 4, 3, 2, 1 on the right can just simply cancel out. The minus 4, by the way, is because 4 choose 3 is just 4, as I described a second ago. But going back to the calculation on the left, the 4, 3, 2, 1, you can simply draw a line through it and cancel it out, leaving you with 7, 6, 5 over 3, 2, 1. How do we work that out? Well, notice the 3 times 2 in the denominator, that's 6. That cancels out with a 6 in the numerator, leaving you with 7 times 5 over 1. 7 times 5 is just 35. So we have 35 take away 4, which is 31 ways of doing this. We worked out that there were 35 ways of selecting these 3 people for promotion in total. Take away the 4 ways that we don't want, where we get all men, giving us the 31 ways to get at least 1 woman when we're promoting. The final thing I would say about this question is the key moment. I'd say actually there were 3 key moments. The first key moment was noticing the phrase at least. They didn't want specifically 1 woman, they wanted at least 1 woman. The second key moment was deciding whether it would be easier to work out 1 woman, 2 women, 3 women, or just work out the opposite, 0 women. And obviously 0 women is easier. So that's the second key moment, saving us a lot of time. And the third key moment, after applying this formula, total minus not equals what we want, was realizing that the not, choosing 0 women, meant choosing 3 men. And then we had to apply the formula among the men to work out how to choose 3 men. Those are the 3 stages of getting these kind of questions right. So let's apply that now to Messidor 08's comment and question. I have tweaked the numbers ever so slightly, as I've said, but this is more or less what he asked me. Messidor must pick 5 books. There are 5 science fiction and 4 non-fiction books to choose from. At least 2 of the selections must be science fiction. How many ways can Messidor pick the books? If you're feeling brave, try the question yourself. We're basically going to use the same method again, but if it's still quite complicated, then obviously just listen to my explanation. Okay, so first we've noticed the phrase at least, hopefully. They want at least 2 of the books to be science fiction. So now we need to make the decision. Will it be easier to work out what they want or what they don't want? So for at least 2 of the books to be science fiction, that's 2 books being science fiction, or 3 books being science fiction, or 4 books being science fiction, or all 5 books being science fiction. That sounds to me like a lot of calculations. No, let's reject that. Let's work out the opposite of what they want. How can we fail to get 2 science fiction books? Well, by getting 1 science fiction book only, or getting 0 science fiction books. And those are only 2 calculations where we fail to get what we want. So we're going to do the same thing again. Find the total number of selections possible with no conditions attached. Take away those 2 failures, and that will give us what we want. Basically, this formula again. What are the total number of selections possible with no conditions? Well, I can count 9 books in total. Doesn't matter, science fiction, non-fiction, just 9 books in total. And we're going to choose 5, so it's 9 choose 5 for the total. What are the 2 ways, as I've just said, of not getting what we want? Well, if we ended up choosing 1 sci-fi, that's a failure. Or if we chose 0 sci-fi, that's a failure. So that is the calculation we're going to do. 9 choose 5 for the total, take it away, choosing 1 sci-fi book, take away choosing 0 sci-fi books. If you didn't know what to do, but now you understand, you can pause the video and try and finish this off yourself, because there's still some little hard bits left. The hard bits that I'm referring to are working out the implications of those 2 failures. Choosing 1 sci-fi, it's not just like a formula I can just plug in. How do I choose 1 sci-fi? Well, the way to choose 1 sci-fi is to choose 1 sci-fi and 4 non-fiction? The question's not going to tell you that. The way to fail by choosing one sci-fi is to have one sci-fi and therefore the other 4 choices being non-fiction. That's how you end up with one sci-fi, given that we're picking 5 books. Notice also that we have to separately work out both failures. We can't find out the total number of ways of failing all in one go. We have to consider each failure on its own. Choosing one sci-fi book is a failure, and how does that happen? Well, if we chose 4 non-fiction and 1 sci-fi, then we're going to work that out. And then we later on have to work out separately the way of failing by choosing 0 sci-fi. Let's quickly do this one. How can we choose 4 non-fiction and 1 sci-fi? Well, there are 4 non-fiction books in total, so it's 4 choose 4 for the non-fiction, and there is 1 sci-fi book that we're picking out of 5, so it's 5 choose 1. Quick hint, by the way, if the number is the same, like 4 choose 4, the answer is just 1. Do you remember how we saw earlier, if the n was 1 bigger than the r, like 4 choose 3, the answer is just n, or 4. If the number is the same, like here, 4 choose 4, the answer is just 1. Final shortcut, just to tell you, I know this is a lot of notes you must be taking, but I'm aiming at the more advanced students. If there's just a 1 at the bottom, like 5 choose 1, the answer again is just n. So 5 choose 1 is just 5. 6 choose 1 is just 6. 8 choose 1 is just 8, etc. So there are these little shortcuts we can take instead of working things out in full. Anyway, what's the other failure? The other failure would be choosing 0 sci-fi. But how could that happen? To choose 0 sci-fi, we have to choose 5 non-fiction. But there are only 4 non-fiction, so it's impossible. So we don't have to consider that failure because that failure can't happen. We can't choose 0 sci-fi because then that would mean choosing 5 non-fiction, which is impossible. So that can't happen. So there's only one failure to calculate. That's the 4 choose 4 times 5 choose 1. The reason it's times, by the way, is because it's and. We're choosing 4 non-fiction and 1 sci-fi. So and means times in probability and combinatorics. So we multiply those 2 answers. Therefore, the only maths left to do really is that 9 choose 5 to find the total. 9 choose 5, we apply the formula. Again, we cancel loads of stuff out. Notice the 5, 4, 3, 2, 1 on the left at the bottom cancels out with the 5, 4, 3, 2, 1 at the top, giving us 9 times 8 times 7 times 6 only on the top, and then the 4, 3, 2, 1 at the bottom. Quick shortcut, the 4 and the 2 in the denominator become 8, right? And that's going to cancel out with the 8 on top. The 3 in the denominator cancels out with the 6 at the top to become a 2. This is the moment where some even smarter students kind of slow down and take too long. They don't cancel out enough. Obviously in the GRE you have a calculator, but even so it takes extra time to type it all in. But really you want to be cancelling out as much as possible. And there will always be lots of cancellations you can do. If you need to, pause the video and just watch how I cancelled it out. The 4 and the 2 in the denominator became 8. 4 times 2 is 8. So you can cancel it with the 8 on top. There was just a 3 times 1 at the bottom. And the 3 cancels out with a 6. It could have also cancelled out with a 9. Either way you get the same result. 3 cancel out with a 6 becomes 2. So the only things left on the top are a 9, a 7 and a 2, which if you multiply becomes 126. So there are 126 ways in total of selecting 5 books with no conditions attached. Taking away the 2 failures, well, one of the failures is impossible, getting 0 sci-fi. The other failure is 5 times 1, which is 5. So total 126, take away that failure equals 121 ways of getting what we want. Picking those 5 books with at least 2 of them being science fiction. Tough question, I think you'd agree, but notice how the method stays constant and clear. I hope, by the way, that answered your question if you're watching Messidor, but I tweaked your numbers because the actual numbers you gave me, it would be impossible to work out because it didn't make sense. But I think you were making up numbers to give me an example to use. So I hope this really helped you with that. Either way, there's a final question that we're going to come to now. And I've called it, as always, the boss level, because this is the hardest kind of version of this question that I can come up with without bringing probability into it, which would be another whole video. So if you want, pause the video, try this one. It is, as I say, significantly harder, but still possible using that method. So good luck. Now for my explanation. Ashley has 8 films on her to watch list, of which 3 are fantasy, 2 are action, and 3 are drama. If Ashley wishes to select 3 films to watch over the coming weekend, how many selections are possible if she wishes to watch no more than 1 fantasy film? As I've written at the bottom, no more is the new at least. Yes, in a way. No more sets a maximum. Very similar concept to at least. You don't have to be worried about it. It's basically the same thing, except this time it's a maximum rather than a minimum. Let's consider getting what we want versus not getting what we want and see which one's easier to work out. Here, getting what they ask for, no more than 1 fantasy film, means a cap of 1. So the way of getting that would be getting just 1 fantasy film, or another way would be getting 0 fantasy films. Those are the 2 ways that we can get what we want. Both of those are at or beneath the cap of 1 fantasy film. So there's 2 ways only. Sounds okay? What about the ways of failing? How can we fail to get a max of 1 fantasy film? By getting 2 fantasy films or 3. Notice there are 2 calculations there. So it's 2 for getting what we want, or 2 for getting what we don't want. So actually in this question, this is a good example of you don't necessarily need to do total minus what we don't want. We could just work out what we want. I might do that at the end. That's not the approach that I'm going to take because I've taught you the other way. But I'm just showing you how it's possible just to work out directly what they ask for rather than doing total minus the opposite. But let's do total minus the opposite now, just because I've shown you that already. And then if we've got time at the end, I'll show you the other way of doing it. What's the total with no conditions attached? Well, there are 8 films and she wants to watch 3 of them. So that would be 8, choose 3 is the total. What are the 2 failures? Well, no more than 1 fantasy film means a cap of 1 fantasy film, which means failing would be her choosing 2 or choosing 3. Then we have to think about what do each of those failures mean. If she chooses 2 fantasy films, that means one of the films she chooses is a different category. And some of you might have been intimidated by the fact that there are 2 other categories, but we can just lump them together. Either way, she's choosing 2 fantasy and 1 other type. So that's 2 fantasy and 1 other. What are each of those combinations? The 1 other will be out of 5 others in total, so 5 choose 1. The 2 fantasy would be out of 3 fantasy in total, so that's 3 choose 2. And we would multiply those to get the answer because it's an and. So 1 other out of 5 others in total, that's the 3 drama and 2 action, that's 5 others in total. Don't worry about the difference between the 2 because it doesn't matter, they're just not fantasy. 5 choose 1, and then the 2 fantasy out of 3, 3 choose 2. Now with the 5 choose 1, do you remember I told you that if 1 was the R, the answer is just the N, which is 5. And do you remember also that I told you when N is 1 greater than R, like 3 choose 2, the answer is just N, which is 3. So without spending a lot of time, we can say that 5 choose 1 is 5, 3 choose 2 is 3, and 5 times 3 is, of course, 15. So that's the first failure we've worked out cleanly and nicely. The second failure is choosing 3 fantasy. Choosing 3 fantasy means choosing 0 other and 3 fantasy. So the 0 other is, we don't need to work anything out. 3 fantasy is out of 3 fantasy in total, and 3 choose 3, whenever it's the same, it's just 1. So that's 1. Those are the 2 failures. Now the total is 8 choose 3, and we can apply the formula. That's not too hard. The 5 factorial cancels out, leaving you with just 8, 7, 6 on the top, 3, 2, 1 at the bottom, and as before, the 3 and 2 cancels out with the 6. That usually happens, to be honest, leaving you with 8 times 7 at the top, which is 56. So there are 56 different ways of choosing 3 films with no conditions attached if you've got 8 films available, minus these 2 failures, which would be choosing 2 fantasy and choosing 3 fantasy. If you take away those 2 failures, we get the correct answer of 40 ways of watching these 3 films with no more than 1 fantasy. And that's the answer, and we can stop there and celebrate if you got that right. Just quickly, for those curious, you don't have to watch this if you're not, but what if we had done it the other way? Instead of doing total take away the failures, what if we had just gone straight for the successes? I just want to show you how that gets the same answer. Well, there are 2 successes if they say no more than 1 fantasy film. No more than 1 fantasy film means a max of 1. The 2 ways of obeying that is to watch 1 fantasy film or 0 fantasy films. This we're going to have to do in our head. I haven't written this down, but 0 fantasy films means that all 3 that we picked were other. 5 choose 3, 5 other films in total, and we're picking 3 of them. Let's do that in my head. 5 choose 3 is 10. So that's 10 ways of watching 0 fantasy films. What about watching 1 fantasy film, which is the other way that they wanted 1 fantasy film? 1 fantasy film out of 3 in total, 3 choose 1, that's 3, times by, we'd then have to pick 2 others out of 5. And 5 choose 2 is, again, 10. 3 times 10 is 30. And if we had the 10 ways of picking 0 fantasy films, the 30 ways of picking 1 fantasy film, that gives us 40 ways of getting what we want, which we had already worked out the other way. So that just shows you that the 2 ways of doing this both give you the same result. You might find it safer and easier just to stick to the method that you can see on the screen because it is super reliable. Either way, incredibly complicated topic. I hope I've made it a little bit clearer and given you at least a reliable shot at getting these kind of questions right. If you learned anything, please leave a like, leave a comment. Otherwise, see you in the next video.